We are looking over here at a shaded region is bound by three items. One is your x-axis, the other is vertical line x equals 1, obviously y equals x squared. This shaded region, if it were to revolve, rotate around the y-axis, a vertical line of axis, you can imagine a solid developing which looks like this. And then when you give it a three-dimensional attribute, you have a volume of a solid which represents in the following way diagrammatically. This is what we have. A three-dimensional solid develops. If I were to take a slice out of this and bring out that slice and look at it from a certain angle, that slice would be a slice of a washer. So you're looking here at a washer method of determining a volume of a solid. Here's your y-axis coming through. You have a certain inner radius and an outer radius. What is the inner radius? You're going from your line of axis to your closest curve, which is y equals x squared. Everything here will be a dy integral. Y equals x squared is no different than x is equal to root y. So your inner radius from your y-axis to this first curve is going to be root y. You have an outer radius going from your y-axis up to this x equals 1, so that's just 1. But each of these slices are circular, so area is equal to pi r square for a circle. Then these become in terms of area inner and area outer. You're taking these radii and squaring them. You'll have a pi y and a pi 1 square, which is just a pi. Your volume integral here is going to be in the following way. In terms of a vertical line of axis, a lower limit, upper limit, you have an area outer minus a area inner. You're integrating this washer area, which is represented by area outer inner area, because it is solid in one part and empty in the center. As you see, you have emptiness here and solid around it. And yeah, with respect to dy, what are my limits? You're going from a 0 up to this 1. Because if I put x equals 1 and y equals x squared, you are going as high as a 1. From a 0 to 1, I have my pi minus pi y, outer minus inner area dy. Isolate the pi and push it out. 0 to 1, 1 minus y dy. Integrate this. It's polynomial integral. You have a pi antiderivative y minus y squared over 2. 1 and a 0. 1 and 0 in places of y, and the difference is no different than a 1 minus 1 over 2, which is a half. Half times pi. Pi over 2 is my volume with respect to y. Pi over 2 units cubed, what are those units are? But this volume determination is correct. Pi over 2 is correct, and we have used the washer method for determining a volume. The area of a washer is integrated from a lower limit to upper limit to give you your desired result.